Welcome back. Today we're going to look at a different type of method to solve systems of equations, and that's going to be our substitution method. Yesterday we looked at how to use the graphing calculator and the Desmos calculator, and today we're going to look at substitution. This is a pretty common method. It's really one of your most standard algebraic methods, and it's all based off of that word, substitution. So let's get started with that. We recognize that I've got two expressions here and they both say that y is equal to those expressions. So what I want to do is, because I know that y is equal here to -3, I'm going to take that -3 and I'm going to put it anywhere that I see y in the other equation. So I'm basically going to take this -3, put it there where the -3 is. And that really leaves me with -3 equals 7x minus 10. Now you can notice I have one equation that I can solve for x. So for this particular equation, it looks like I would add 10 to both sides. And I would get 7. And then I divide by 7 to find out that x is equal to 1. Well, now I know the x value is equal to 1. So my ordered pair answer is going to be 1 something. Well, there's the x value. The y value, I need to do one of two things. One, I can just come right here and look. They've actually already told me the y value is -3. But typically that doesn't happen. So what I could do is I could use this equation and I can plug in and solve for y. Remember, y equals 7x minus 10, and since I know x is 1, I can plug in that 1 to find out that 7 minus 10 is -3. So of course I already knew it was -3 here, but this just confirms it. -3. I can also confirm that using my Desmos calculator, and you can see by graphing y equals 7x minus 10 and y equals -3 clearly crosses at 1, -3. Let's try one more example. This one's a little bit more typical of what you'll see. This time again I have two expressions and they're both equal to y. Because I have them both equal to y, I know that I can plug in either expression into the other one. It wouldn't matter which one. Last time I did the bottom into the top, so this time I'll do the top into the bottom. Since y is equal to 6x, I know that right here is a y. So I can plug it in for this y down here. So that's exactly what I'm going to do. I'm going to take this 6x and plug it in right there for y. So that's going to leave me with 6x equals 5x plus 7. At this point, I have one equation with one variable, and I can solve from here. So to solve this one, it looks like I'm going to subtract 5x, and that'll leave me simply with x equals 7. Now again, for an answer, my x value is 7. So I know that that's a good start. Now how do I find the y value? On the last example, the y was given to me, but in this case, I don't know. So I get to choose either one of these equations. Both of these equations will give me the value of y. I just get to choose whichever one I'd like. I'm going to choose the top equation because I believe it looks easier. Y equals 6x. If I plug in this x into this 6 times 7 is 42. So I know my y value is 42. Now I could have done it here. 5 times 7 is 35. 35 plus 7 is 42. It would have still given me the same answer. And I can confirm all of that as well by looking at Desmos and seeing where the intersection point is. So my answer is x equals 7. Y equals 42.